Full packet capture is exactly what it sounds like. It captures the entire binary content of packets that cross the network. Usually the data is stored in PCAP format. The storage requirements for full packet capture can be immense and the data may be tedious to analyze. Storage requirements and policies must be considered with full packet capture. Full packet capture can quickly consume disk space. For example, if we have a link that averages 50 megabits per second throughput, full packet capture will consume 540 gigabytes of storage every day. So consider your overall storage requirements for all NSM data types. And by default though, Security Onion purges data based upon drive utilization thresholds of 90% or higher. Although the value of full packet capture is undeniable, full packet capture can be used to answer questions that can't be answered with any other NSM data types. Security Onion uses NetSniff-NG to perform the full packet capture. Security Onion offers several tools that can be used to analyze the PCAP files that are produced by NetSniff-NG. Those tools include Wireshark, T-Shark, TCP-Dump, and CapMe. Here I have a sample using Wireshark to display the contents of a PCAP file. You can see that there is a lot of raw data contained in the capture. At the top, we have individual packets themselves, which provide information such as source and destination IP addresses, port numbers, and protocol. By selecting an individual packet, we're able to see more detail or a decode of that packet. And down at the very bottom of this example, the raw data is displayed in binary and ASCII format. Placement of sensing interfaces will affect which conversations will be seen. Generally, sensing interfaces are placed at choke points in the network. Examples would include ingress points behind an internet-facing firewall, or into the data center, or even ingress points for remote access VPN. A single sensing interface could be connected to a switch port which mirrors traffic, and this is often called a span port. This is the least reliable method because packets may be missed. The mirrored port allows full duplex connectivity, and that may overflow the capacity outbound from the mirroring interface. Another option is the network tap, which splits a duplex connection into two separate simplex connections. This allows a sensor to dedicate two interfaces that receive traffic from the tap. While this guarantees network bandwidth, it does not necessarily guarantee compute capacity to handle the packet capture. The most reliable connection method is inline. This is the method where the sensor uses two interfaces and traffic is forced through the sensor between those two interfaces. This does, however, make the sensor a bottleneck. If the sensor cannot forward the frames at wire speed, network performance may suffer. But since the sensor will only forward the packets that it can process, it guarantees that no packets are delivered which are not recorded by the sensor. In today's networking environment, certain aspects of packet processing that were originally done by the operating system can now be offloaded to the NIC. Examples include the checksum and TCP segmentation offload. This offloading can improve system and network performance, and from an NSM perspective, it is critical that the packets that are captured are exactly what is transferred on the network. Care must be taken to ensure that the offloading features are disabled on full packet capture interfaces though. Security Onion though, for example, automatically disables these offloads on its sensing interfaces.